Section 7.6, Laws of Cosines and Sines. In Section 7.6, we are going to look at solving non-right triangles. We are going to do that by using the law of cosines and the law of sines. In the process, we are going to look at a number of application or word problems in order to demonstrate the use of the laws. So, our primary interest in this section is going to be solving non-right triangles. So these will be triangles that do not have a right angle. It'll be important when you do problems on homework and tests and things that you recognize when the triangle is right and you can use SOHCAHTOA, and when the triangle is not right and you have to use either the law of sines or the law of cosines. Just to remind you that a triangle that is not a right triangle is called an oblique triangle. And we're going to actually take a look at kind of how the problems get set up and the way I'm going to set them up. So again, here's my triangle. Even though angle B you might think looks a little bit like a 90-degree angle, it's not. And so what we'll do is we'll have our three angles. I'll be calling them A, B, and C with capitals, and the signs opposite them, little a, little b, and little c. And so notice that side A faces angle A, B faces angle B, C faces angle C. In this section, we're going to look at ways of solving triangles. Sometimes we won't need to find all of the sides, but we're going to start off by looking at ways to find all of the sides and all of the angles. And in each of these cases, we're going to be given 3 of the 6 parts of the triangle, and at least one side must be provided. So you get 3 of the 6 3 of the 6 pieces, but at least one has to be a side. And then the information we're given will determine our approach. So the situations that we're going to see are going to fall into these 4 categories. We're either going to be given the lengths of all 3 sides, which sometimes people refer to as side, 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 or we're going to be given the length of 2 sides and the included angle. And just to remind you, the included angle means the angle formed by the 2 sides. So what's going to happen is we might know side A and side B, but then we would know angle C. So what actually happens is we'd know 2 sides, and then remember the third angle would be the angle that has the letter that we haven't yet used. The third situation is we'll know the length of 2 angles and the included side. So again, what we'll actually have is an angle and then a side and then an angle. So typically you'll see people call that angle, side, angle. And so what's going to happen is you'd have a side and you'd have the angle on each side of it, but you wouldn't know the angle that's opposite that particular side. So what would happen is you'd know like angle A and angle B, and you'd know side C. So again, we're going to know 3 items, none of which are paired together. And then the last situation that we would have is what would we knowing the length of 2 angles. No, excuse me, I should say length of 2 angles and a non-included side. So I'd have angle and angle, but the side that I would have would be a different side, and so that would be what we might think of as kind of an angle-angle side. We could also, and I should tell you this, one of our situations is side-side angle. We want to be really careful that we clarify what we have each time. It'll really help the problem, and it'll help us determine what our best approach will be.